Good morning, students. And we are starting with the software models. We have discussed the various models like uh, waterfall model, iterative waterfall model, and prototyping model. Today we'll discuss other models that are left on that day. And am I audible to everybody?
Yes, ma'am.
Okay. So you can see on the screen here that I have drawn a diagram in which there is a dot, and after that dot there is another diagram which represents a dot and a circle, and another diagram in which a dot and both circle is there. So what does this represent? You can see in the diagram here, this represent a kind of evolution. Suppose a core is developed, and from the core uh, a layer is developed around the core, and after some time when the customers are or the person who are developing are satisfied, another core is being developed. So uh, we'll be studying the model that is called evolutionary model here. What does evolutionary model do and why this name arises? Just because the model सॉफ्टवेयर इंजीनियरिंग मॉडल, अभी तक ये चीज क्लियर हो जानी चाहिए to everybody in this class that what is basically a software model and what do you mean by SDLC. I am repeating a little bit about the previous lecture just because कि बहुत time हो गया है. After 2 weeks this class is coming, and SDLC stand for Software Development Life Cycle. जैसे हर बंदे का human being का every creature has a life cycle. The same thing happens with the software. Software has a life cycle. So whenever we are developing a software, it goes through various stages, and those stages are called phases. Like I already told you, feasibility study, requirement analysis, gathering and analysis, software design, coding, implementation, maintenance, implementation, testing, and maintenance. So that is we can say software development life cycle. Every software has that SDLC, but a model is a different thing. What does model mean? How these phases can be arranged according to the requirement of a particular type of software, we can say. So software development life cycle comes under every model. आप evolutionary पढ़ो, you can study waterfall model, you can study iterative waterfall model or incremental model or prototyping model or evolutionary model or the spiral. So in every model this software development life cycle will be there, but there may be possibility that the sequence of those phases will be different in every case just because the requirement for developing a particular kind of software is different. So we'll be starting with the evolutionary because we are done with the waterfall model and iterative waterfall model and prototyping model. Now we'll be starting with the evolutionary model. So what does this evolutionary model says? Evolutionary model is uh, developing a model in successive versions or incremental model. The system is broken down into several modules. एक एक प्रॉब्लम है उसको छोटे छोटे पार्ट्स में डिवाइड करते हैं, दैट इज कॉल्ड एज मॉड्यूल्स. वी हैव डिवाइडेड इनटू मॉड्यूल्स व्हिच कैन बी इंक्रीमेंटली implemented and delivered. So you can see in the this diagram here on the board, this represent the dot represent the first core. After that core the next layer is being developed, and after that a next layer. The system is broken down into several modules which can be incrementally implemented and delivered. First, develop the core modules of the system. आप किसी भी सिस्टम को बनाना चाह रहे हो, but you are not aware कि आपको तो स्टार्ट ही पता है. You know the start, you know the core. So you start developing from the core. First, develop the core modules of the system. The initial product skeleton is refined into increasing levels of capability. आपको एक initial skeleton बन जाएगा, आपको पता चल जाएगा अब कहाँ जाना है. By adding new functionality in successive versions. So in successive versions of that software, we are adding the new functionalities. That should be our concern. Successive versions of the product include functioning system capable of performing some useful work. So in every layer we are developing, we are adding the functionality. ऐसा ही नहीं कि बस ऐसा ही कुछ develop हो रहा है. We are developing the functionality one by one layer. A new release may include new functionality. कोई new release आता है. Also, existing functionality in the current release might have been enhanced, or it may be possibility that existing functionality may be enhanced. जो पहले थी उसको हमने क्या किया? We have enhanced that functionality. So you can see here, this is A is the core part, and after core a B layer is also developed, and after A, B as C layer. You can see here this A is blue, B is the white part, and C represents this pink part. So it includes rough requirement specification. What will be the sequence of that very thing? Rough requirement specification, identify the core and other parts to be developed incrementally. Develop the core part using an iterative waterfall model. So whenever we always remember one thing, whenever we are developing evolutionary kind of thing, we have developed the core part. But what will be the approach of developing the core part? That will be the iterative waterfall model approach. ये जो core part हमने develop किया, that is iterative waterfall model. After iterative arrangement, a core is developed. So what is the next? You know that in every software engineering development, like every software development, there are stakeholders. Stakeholders वो होते हैं जिनको उनसे उस सॉफ्टवेयर में जिनका कंट्रीब्यूशन होता है. तो कंट्रीब्यूशन ऑफ customer, system analyst, software engineer, software tester, and every person who is associated with the software are called stakeholders. So customers are also stakeholders. We'll collect the information, or if we can see the feedback from the customer, and if they feel like, if customer feel this feedback, from the feedback that there needs to be some kind of modification to be done, the customer will suggest these changes to the system analyst or the system engineer, and after changing those requirements, we'll develop the next identified feature using an iterative waterfall model. हम क्या करेंगे? If there are changes, we'll modify those changes in the core, and we'll develop the next identified features using an iterative waterfall model. So when all features are complete, we are done with the system, and the next, what will be the next phase? That will be the maintenance. So you can see here, well, whenever we are developing a next identified feature using an iterative waterfall model, we deliver the next version to the customer. You can see here feedback loop is here. Every layer, every version you are developing, you have to show it to the customer that this is the next version, this is the next version, this is the next version. अब मैंने इतना बना लिया, हमने ये कर दिया. You can see, and you can come on our site and see whether you are satisfied with the half of the project, whether you are satisfied with the 70% of the project, whether you are satisfied with the 80% of the project. So this way you have to take into consideration the feedback of the customer. That is the concern. When all features are complete, you are done with the whole project or whole software. Project is basically a software development. When you are done with everything, then comes a phase that is called the maintenance. What does maintenance mean? Maintenance mean you need to maintain that software up to that standard. Why? Because whenever you are delivering that software to the customer, what you need to do is, वो customer अपने level पे, अपने side पे, they will perform some kind of testing. After doing testing, they will use that software, or it may be possibility some kind of bugs or some kind of errors may arise with the usage or with time. So maintaining that kind of software, that phase of removing bugs or error, that is called testing, as well as a next phase that is called maintenance. Because whenever we are doing testing, there are two types of testing. It is on the whenever we are developing the software, and after bugs are introduced, when we have delivered the product to the customer, that is a kind of maintenance we can say. So uh, always remember, whenever you are dealing with the evolutionary kind of approach of software development, you need to specify the rough requirements. I'm repeating again the steps. Rough requirements. After rough requirement specification, identify the core. Core को identify करो. Identify the core and other parts to be developed incrementally. ये model है increments में develop करो. We need to develop the things incrementally. Or we can say the problem that are to be solved using some kind of incremental approach comes under this type of evolutionary kind of model. Well, the core part using iterative waterfall model, again collect customer feedback and modify requirements. Well, the next identified features using an iterative waterfall model, and deliver delivery to the next version to the customer. Every time you have to show to the customer all features complete, then comes the maintenance. Is that clear to everybody? I hope this evolutionary is clear to everybody. Now, what are the advantages? User get a chance to experiment with the partially developed system. User को एक chance मिल गया, छोटा सा part. The user can see a partially developed system much before the full working version is released. Before full version of working version of the software, the customer of that very software will be able to see how this system is going to work. It helps in finding exact user requirements. आपको कोड से पता चल जाएगा कि आपने जो requirement set की थी, what you have set, whether it is according to that or not, much before fully working system is developed. Core module get tested thoroughly. So, but what is the advantage that you have tested the code? Sometimes, what is the problem? What kind of problem arises is we have developed the software, and later on we came to know that the core is not developed according to the requirement specification. So in that case, it is a major drawback of the software, as because core is not developed properly, the whole system is we have developed is of no use to the person or the customer. In that case, we have wasted a much effort in case of time as well as money. So to avoid such kind of effort wastage of effort, what we can do, we can use an evolutionary kind of approach in which core modules get tested thoroughly, and that reduces the chance of error in the final product. Now, what are the disadvantages of evolutionary model? Often difficult to subdivide problems into functional units. Whenever we are developing any kind of software, always we have an issue कि हम divide कैसे करें? How can we divide a problem? आपको ही एक software मिल जाता है, like I can say the software, आपको बोला जाता है you have to develop a software for passport system. ठीक है, पासपोर्ट इशू करने का सॉफ्टवेयर बनाना है टू द पीपल ऑफ अमृतसर और टू द पीपल ऑफ इंडिया और टू द पीपल ऑफ पंजाब. So that will be a big project for you. And if you people are told as a we can say group of 5 to 7 or 10 people or 20 people or 50 people, that you are to divide the problem, that will be difficult to subdivide, because you may not have that kind of uh, uh, experience to divide the problem. But doing some kind of practice, or we can say developing software of smaller, or developing software for smaller organization, will give you an experience to divide the problem into subparts or functional units. And if you are able to handle such kind of problem, that will be good enough for you. So disadvantage of evolutionary model is sometimes it is very difficult to subdivide the problem into functional units, which can be incrementally implemented and delivered. Not every product is can be developed incrementally. हम हर किसी प्रोडक्ट को नहीं हो सकते that it can be developed incrementally. There are special kind of we can say softwares that can be developed incrementally. Evolutionary model is useful for very large problems. So अब जब प्रॉब्लम ही छोटी होगी उसको क्या आप कोर में डेवलप करोगे, क्या लेयर्स में डेवलप करोगे, एंड व्हाट यू कैन डिवाइड इनटू सब प्रॉब्लम्स. If problem is very small, you cannot divide into sub problems. So evolutionary model is only useful when there is a very big problem, or problem का मतलब क्या है, the project or software development is very big. So for large projects or large problems, you need an approach that is called evolutionary model, where it is easier to find modules for incremental implementation. आपको easy से module का पता चल जाए जो increments में you can develop the problem in increments. Now evolutionary model with iterations. From the evolutionary model with iteration have some kind of advantages. From the iteration we mean repetition or iterative way. So several advantages are there. Training can start on an earlier lease. Customer feedback taken into account. The screen is showing some kind of iteration here. This, as you are repeating, iterating. Many organizations use a combination of iterating and incremental development. Iteration or incremental development. A new release may include new functionality. Existing functionality from the current release may also have been modified. So in case of evolutionary with iteration, the advantages are training can start on earlier release. You can start the training of how to develop the next part. Customer feedback can be easily taken into account. Markets can be created. You can easily identify the customer who needs such kind of software, because you are in developing the software incrementally, so you can release a part of your software for marketing purpose, for functionality that has never been offered. आप marketing कर सकते हो, ये functionality पहले नहीं थी, we are offering a evolutionary approach with iteration, so more of the customer you can attract accordingly. Frequent releases allow developers to fix unanticipated problems quickly. So frequent releases will give the developer a kind of freedom to anticipate problems quickly, to find those problems quickly that were not earlier easily we can identify whenever we are not developing our products in the form of increments with iterations. Now the applicability, as I already told you, the applicability of incremental kind of approach is for the larger software. Okay, where it is easier to find modules of incremental implementation. It to have we are to develop larger projects using evolutionary model. But what other projects we can develop? Yes, we can develop object oriented software. The software that need object oriented development can also be developed using the evolutionary kind of approach. So always remember, whenever a question comes in the exam or any paper or in objective type, whenever you have large project and there are they are easily identifiable identifiable functionalities, so you can do with the evolutionary kind of approach. And if object oriented development is required, you can use evolutionary kind of approach for development. Next is the spiral model. Now what is this spiral model? This spiral model is a model that was developed by Bohem. Anji, Anchal has raised her hand. Anchal, is there any question?
Yes, ma'am.
Anji, you may write your question in the chat box.
Ma'am, chat is disabled.
Chat is disabled. Okay. Ask then.
Ma'am, can we say that prototype model is a kind of evolutionary model?
We cannot say prototyping model is of evolutionary. You want to say that prototyping is evolutionary? They are similar.
Ma'am, if we basically say that in case of prototyping model, we basically develop a prototype and provide it to the customer and check it. So
Hmm.
over there also we are checking the particular kind of prototype.
Okay.
So we
See, I'll tell you the difference between both the these approaches like prototyping and evolutionary. In case of prototype model, we are not concerned with developing the core part. We can develop any part in the prototyping model. We just want to see whether what we are setting as requirement is basically converted into design accordingly. That is the concern. हमने वहाँ ये बात नहीं की प्रोटोटाइप में हम we are developing the core part. ठीक है. Other thing is in the prototyping case we are developing, though we are developing a, we can say a prototype, हम एक ढांचा बनाकर ये देखना चाहते हैं जो what we are going to develop is whether we are going on the right side. It may be possibility that we develop the last functionality in the prototype. हम कोई भी functionality पकड़ के prototype में develop कर सकते हैं. ठीक है. But in case of evolutionary we are talking to develop the software in the form of core. We need to develop the core first, and after we are to develop the increments, and we have to show the every increment in we can say in the case of evolutionary model. But in case of prototyping model, what we are doing is we are developing a functionality just to see whether it will behave the way we want it to, and after we are satisfied with the prototype, we can move with the prototype, और हम उस prototype से किसी तरफ भी move करके project को we can develop that project. Other thing is in a prototyping model there is approach called throw away prototyping. अगर prototype ठीक नहीं बना तो हम उसको फेंक देंगे, will destroy the effort we have applied on that prototype. But in case of evolutionary kind of approach, we will not destroy that product. We'll try to convert, we'll try to change according to our requirement. So in that case we are not throwing away. So that is a concern in the case of evolutionary kind of approach. मतलब क्या, मैं आपको एक पंजाबी की सेंस से एक बिल्डिंग है, हमने एक बिल्डिंग बनानी है, एंड व्हाट वी आर डूइंग, हमने एक कमरा बनाकर उसका आर्किटेक्ट उसका देख लिया वो कैसे है, वो रूम ठीक बना है कि नहीं, और रूम अगर ठीक बना उसके आगे पीछे हम ऐसी सेटिंग करके बाकी सारी बिल्डिंग जो तैयार कर ले, दैट इज वी कैन से अ प्रोटोटाइप. ठीक है. और अगर हमें वो रूम ठीक नहीं लगा तो हम वो रूम को हटा दें कि ये ठीक नहीं बना, दैट इज अ प्रोटोटाइपिंग अप्रोच. बट इन केस ऑफ एवोल्यूशनरी विल सी द कोर पार्ट, विल सी एक बिल्डिंग बनाने में सबसे पहले कोर कौन सा रूम बनाना है ठीक रहेगा, and if that room is not according to the choice of that very particular customer, will not destroy that room, we'll try to change that room. And after changing that room, after changing that structure of that room, we'll show to the customer, and after that we'll develop the next layer of that work. So that is the concern here. I hope you can now differentiate between what is, though they are little bit similar but not totally similar. We have to show it to the customer. Basic concern is in both the evolutionary as well in prototyping model. But prototyping में ये है, we can throw the prototype, but in case of evolutionary module is core module, and we cannot throw the prototype, or we cannot throw the evolutionary model. I hope that is clear to everybody. हाँ जी अंचल.
yes ma'am, हो गया clear.
अगर फिर भी नहीं क्लियर हो, यू कैन आस्क मी अगेन आफ्टर द क्लास. आई होप अभी क्लियर हो गया होगा. नाउ नेक्स्ट वी आर मूविंग टुवर्ड्स स्पाइरल मॉडल. And spiral model. This model is given by Bohem in 1988. Each loop of the spiral, it is in the form of a spiral. I'll show you how the spiral is going to work. Each loop of the spiral represent a phase of software process. So every loop represents a software process. The innermost loop might be concerned with system feasibility. The next loop with the system requirement definition, the next one with the system design, and so on. So in case of spiral model, what is the basic concern is that The model is developed in the form of spirals. So every spiral represents some kind of functionality associated with it. Spiral model has different quadrants associated with it. First quadrant, second quadrant, third quadrant, fourth quadrant. And every quadrant has some functionality associated with the spiral model. So the innermost loop might be concerned with the feasibility. The innermost loop, मैं यहाँ पे draw कर रही हूँ. The innermost loop might be concerned with the feasibility. The next loop with the system requirement definition, the next with the system design, and so on. So the model is developed in the form of spirals. In the form of spirals. Wait for a minute, there is some kind of problem. Let me see. There are no fixed phases in the model. You need to remember one thing: the spiral model, that there are no fixed phases in this model. The phases shown in the figure are just example. You can see here the diagram of the spiral model. Determine objective. Number 2 is identify and resolve risk. Next is develop next level of product, and the next is customer evaluation of prototype. Can you hear me?
Yes, ma'am.
Can you hear me? आवाज आ रही है to everybody?
Yes, ma'am.
Okay. So you can see
Yes,
on the
ma'am.
board itself. I have marked here the innermost loop on the board here. You can see the innermost loop. What this innermost loop represent is the one of the phase of the software development life cycle. It may be feasibility, it may be requirement analysis, or it may be software design. This loop will move from the first quadrant to the second quadrant to the third quadrant to the fourth quadrant. That means every phase has some kind of objective associated with it. We need to identify those objectives every phase. And after identifying those objectives, जैसे ये this is the inner loop, we can say. After identifying objectives, we are identifying objectives in this phase. This यहाँ से लेके you can see here in the diagram where this arrow is. This represent identifying determining objectives. And after identifying a determining objective, next is identify and resolve risk. Next is to resolve those risks associated with the objectives. Next, third is to develop next level of product in that phase. And fourth is customer evaluation of the prototype. So after developing a single phase, customer evaluation is required. And after going through this thing, a next loop comes. So next we need to develop the next loop. You can see in the diagram here, up this board page diagram, you can see there is a dark line inside, and after that dark line there is another loop that represents the next phase. That may be from the feasibility study, we are moving towards the next phase, that is requirement analysis and specification. And after requirement analysis and specification, the next phase is we can say is uh, uh, um, it may be of design category, and fourth will be called as coding phase. So in this way we can say we have uh, quadrants associated with every phase of software development, and the quadrants are according to the functionality: determining objectives, identifying and resolving risk, developing next level of product, and next customer evaluation of the prototype. So first you can see here, what is the first quadrant? Identify objective of the phase. Number two, examine the risk associated with these objectives. हमने क्या करना है? First quadrant में we need to examine the risk associated with these objectives. Risk कैसा है? Any adverse circumstance that might hamper the successful completion of a software project. अभी रिस्क क्या होगा सॉफ्टवेयर में कि गलत सॉफ्टवेयर ना बन जाए, कुछ और ही ना बन जाए जो हम बनाना चाहते हैं. So that risk may be associated with the, we can say, the feasibility study. And finding alternative solutions of possible, हमने we need to find the alternative solutions. So that is the first quadrant. Objective setting of first quadrant include identifying objective of the phase. उस particular phase के objectives आपने identify करने, उस particular phase के आपने risk देखने क्या क्या है. You need to find the risk. And what does risk mean here? Risk is any adverse circumstance that might hamper the successful completion of the software project. And third is finding alternative solutions to those problems, those possibles. Now the second quadrant. Second quadrant in the diagram you can see identify and resolve risk. जो हमने examine तो किए risk, उनको identify करना और उनको we need to resolve those risks. So second quadrant is risk assessment. Assess करना रिस्क को कितना बड़ा है, छोटा है, 50% है, 20% है, 15% है, 5% है, 95% है. That is risk assessment. And we need to remove those risks. हमने वो उनको खत्म करना है. अगर खत्म नहीं हो सकते, we cannot remove those risks, we can reduce those risks. So risk assessment and reduction is done in the second quadrant. For each identified project risk, a detailed analysis is carried out. Steps are taken to reduce the risk. For example, if there is a risk that requirements are inappropriate, a prototype system may be developed. हमें लग रहा है कि रिस्क क्या है, जो हमने रिक्वायरमेंट सेट किए हैं रिक्वायरमेंट एनालिसिस में, that are not appropriate, वो appropriate नहीं है. ठीक है? So what we can do, a system may be developed in the form of a prototyping kind of approach. So in the third quadrant, what is the third quadrant? I will show you on the diagram here. The next level of product. So in developing and validation is carried out in the third quadrant. Develop and validate the next level of product. अब उसी product की उसी requirement analysis का next level क्या है, उस phase का next level क्या है, and that is the concern in the third quadrant. And what you have developed up till third quadrant, you have to show it to the customer in the fourth quadrant. So fourth quadrant is the last quadrant that implies reviewing and planning. Review the result achieved so far with the customer and plan the next iteration around the spiral. तो आपने एक feasibility की एक iteration complete कर ली after the fourth quadrant, but you need to plan the next spiral iteration about the spiral in the fourth quadrant आपने जो complete की है, जो आपके यहाँ dark line last पे देख रहे हो in the diagram here, this last represents the planning and reviewing for the next form of spiral. So we can say that every spiral, a single spiral, a single circle represents a single phase in the software development life cycle of a spiral model, and having four quadrants that involve determining objectives, identifying and resolving risk, developing next level of product, customer evaluation of prototype. तो पहले हमने ये इतना सा डेवलप कर लिया. After developing till here, we are moving towards the next spiral, that is this way. We are moving towards the next spiral this way. This will complete here, so that will be marked as second spiral. And from here, this second spiral, we are moving towards a third spiral, that is uh, completed here. Here you can see that we are moving towards a fourth spiral, that is ending here. So in this way, any number of spiral you can develop. As in spiral model, there are not fixed sequence or fixed kind of phases. It is up to the we can say that up to the developer side, that they will decide all these phases, sequence of these phases need to be done in every different project. Spiral model as a meta model. Now this model, spiral model is called meta model. ठीक है, मेटा मॉडल का मतलब ये इट दिस मॉडल कंसिस्ट ऑफ ऑल अदर मॉडल्स. इस मॉडल में सभी मॉडल्स आ जाते हैं बिकॉज इट सब एज्यूम्स ऑल डिस्कस मॉडल्स. सभी मॉडल्स का कुछ ना कुछ ये अपने में कैरी करता है. क्या क्या कर रहा है? अ सिंगल लूप स्पाइरल रिप्रेजेंट वाटरफॉल मॉडल. एक सिंगल लूप क्या रिप्रेजेंट कर रही है? इट इज रिप्रेजेंट्स द वाटरफॉल मॉडल अप्रोच. वे एक से अगली जगह पे मूव करो, नेक्स्ट लेवल प्लान करो एंड यू मूव टू नेक्स्ट प्लान. It uses an evolutionary approach when iterations through the spiral are evolutionary levels. आप iterations कर रहे हो, you are creating spirals, एक के बाद दूसरा spiral, दूसरे के बाद. What you are doing? You are developing from the core. एक iteration develop करके फिर next. And this kind of approach is evolutionary approach. Next is it enable understanding and reacting to risk during each iteration along the spiral. And you are using prototyping as risk reduction mechanism here. What you are doing is, if you're feeling that this will lead to some kind of risk, अगर किसी phase में 95% risk आ रहा है, what you can do is you will destroy that part and develop that part again. So that kind of approach will be called as prototyping approach. आपने एक layer develop कर ली, you have developed the first layer, this layer, and after developing this second layer up till here, you realize this the layer you have developed, ये वाली आपने जो develop की this layer, you realize that this is not according to customer requirement. What you can do is you can destroy this layer. So developing and destroying such kind of things means you are doing prototyping kind of approach. So this way you are using the prototyping model, as it retains the stepwise approach of waterfall model. ये waterfall के model की तरह stepwise चल रहा है. That is it is also constituting, we can say, a waterfall model. So this spiral model is meta model just because it is taking features of every other model we have discussed, whether it's evolutionary, whether it's prototyping, whether it's iterative waterfall model approach. So it assumes all other model in one way or the other, and it also covers the risk. In other models that we have discussed earlier, we are not considering risk. But in spiral model, why people follow this spiral model and consider it as a model, meta model? Just because it covers all the concepts of all other model, as well as it also covers the concept of risk assessment and risk reduction. And in risk assessment and reduction, it is using the prototyping kind of mechanism. अगर ठीक है, रिस्क ज्यादा है, उस चीज को कंटिन्यू ना करके उसको डिस्ट्रॉय करके यू डेवलप द नेक्स्ट प्रोटोटाइप दैट विल सेटिस्फाई द कस्टमर. So there are some comparison related to this these models. दिवाकर चौबे. हाँ जी दिवाकर.
गुड मॉर्निंग मैम. मैम
आपकी वॉइस बहुत कम आ रही है. यस
मैम, स्पाइरल मॉडल में तो मतलब रिस्क रिडक्शन के लिए प्रोटोटाइप अप्रोच यूज करते हैं, और फिर स्पाइरल मॉडल मेनली रिस्क हैंडलिंग के लिए ही होता है.
स्पाइरल मॉडल क्या
रिस्क हैंडलिंग के लिए होता है ना, मतलब.
ओके हाँ जी.
तो वो काम तो मैम प्रोटोटाइप मॉडल भी करता है, तो फिर स्पाइरल मॉडल का क्या जरूरी है?
सी इन केस ऑफ नहीं, जरूरी की बात नहीं है. सी प्रोटोटाइपिंग मॉडल वाटरफॉल मॉडल अप्रोच तो नहीं ना फॉलो करा, ठीक है। एक तो ये कोई कंपल्सरी, वी आर नॉट टेकिंग इट एज ए कंपल्सरी कि you cannot take spiral, you cannot take prototyping, you have to take spiral model. Prototyping model is not taking the concept related to waterfall model or iterative waterfall model or evolutionary model, but Bohem developed a combination of all those models. But does Bohem did he developed a model that covers all the combination of all those we can say models that were earlier developed and also cover the risk kind of thing. So he presented a model. आज अगर आपको इससे better approach मिल जाती है for developing any kind of software that is quick and easy to develop, तो वो एक नया मॉडल हो जाएगा. बट वट वी आर डूइंग इज वी आर स्टडिंग ऑल दोज ट्रेडिशनल मॉडल्स दैट कम अंडर द हेडिंग ऑफ सॉफ्टवेयर इंजीनियरिंग. हम ये नहीं, हम एक डिफरेंस तो बता ही रहे हैं, पर ये हम नहीं कह रहे कि प्रोटोटाइपिंग मॉडल वाज देयर सो वी नीड नॉट टू हैव अ स्पाइरल मॉडल. Bohem projected the idea that spiral model is such kind of model that cover the main features of all other models as well as cover the risk. अब प्रोटोटाइपिंग मॉडल तो रिस्क असेसमेंट कर ही रहा है, बट it is not covering the quadrant kind of risk assessment. It prototyping risk identify कर रहा है, but it is not able to reduce the kind of risk. Reduction तो नहीं हो रही ना प्रोटोटाइपिंग में. We cannot reduce the risk. We can only identify. But in spiral, our approach is to assess the risk as well as to reduce that kind of risk. ठीक है. और it is not kind of comparison भी वो था और ये क्यों आ गया, nothing like that. You can also develop your model with your name that will be more effective or more having more features than these models. So people will start following that model also. This is the main concern here. I hope you understand what I'm saying.
Yes, ma'am.
Clear हुआ आपको?
Yes, ma'am.
Okay. So comparisons of different life cycle models. Iterative waterfall model mostly used model है, but suitable only for well understood problems. Iterative वहीं पे use हो सकता है for well understood problems. And next is prototype model. Is suitable for projects not well understood. Prototype वहां पे फिट बैठता है जहाँ पे आपको पता ही नहीं है कि आपने क्या डेवलप करना है, आपको आइडिया भी नहीं लग रहा कि क्या बनेगा. तो यू डेवलप द प्रोटोटाइप. क्या होता है? एक ढांचा होता है, एक टॉय इम्प्लीमेंटेशन, जिससे यू कैन गेट एन आइडिया ऑफ यूजर रिक्वायरमेंट्स एंड टेक्निकल एस्पेक्ट्स. एवोल्यूशनरी मॉडल इज सुटेबल फॉर लार्ज प्रॉब्लम्स and this spiral model is suitable for development of technically challenging software products that subject to several kind of risks. So this spiral covers different kind of risks, assessing those risks, reducing those risks. Now next, agile development models. Before moving towards agile development model, there are two goals. So we're moving towards goals. You need to answer these questions. Which type of model supports successive versions of the product, whether it's evolutionary or spiral? Next is, all are required to answer these questions. This will mark your presence in the class. Your attendance will be marked based on the poll. Uh, Frequent releases allow developers to fix unanticipated problems quickly. In which model this happens? Frequent releases. Remember this thing. Frequent releases. From that you will get an idea whether it's a waterfall, spiral, or evolutionary. Unanticipated problems quickly. Always remember one thing, you need to see the hint that is under the question, in the question. Which type of model supports successive version of the product? Successive version. किसमें थे successive versions? And other one is frequent releases allow developers to fix unanticipated problems quickly. In which model this happens? Kindly be fast. Still, half of the class has not responded to these questions. Kindly be fast. Otherwise, I'll mark your absent uh, as you have not voted for these questions. Frequent releases allow developers to fix unanticipated problems quickly. Still, students are pending. Still, students are pending. I am ending the poll. Kindly reply as fast as you can. Still, some students are pending. I am ending the poll. So, uh, which type of model supports successive version of the product? It's evolutionary. Successive version किसके होते हैं? Evolutionary kind of approach. And next is frequent releases allow developers to fix unanticipated problems quickly. इसका आंसर क्या था? Frequent releases means evolutionary kind of approach. So most of this class is wrong. It is not spiral. It is evolutionary. So next poll is here. I'm launching another poll. You have to see the question and reply accordingly. Just read the questions before replying. Examine the risks associated with the objectives. In which model risks are associated, and which model is called as meta model? Which model is called as meta model? Examine the risk associated with the objective. These लिखा गया with the objectives आना था. With the objectives. Examine the risk associated with the objective. In which model risks are associated? Other is which model is called as meta model. All are required to reply these questions. Only few students have answered yet. Kindly be fast. We have to complete the topic, another topic today, the agile development. So I am ending the poll in 20 seconds. Kindly answer quickly. Examine the risk associated with these objectives. With the objectives, in which model risks are associated. So for both the questions, the answer is spiral model. We examine the risk associated with the objectives in case of spiral model, and spiral model is called meta model. This not evolutionary model is called meta model. So this was all about evolutionary model and spiral model. Now we are moving towards another kind of development that is called agile development. Agile development models. The agile software development. Agile software development model was proposed in the mid 90s to overcome the serious shortcomings of the waterfall model of development identified above. We have studied this waterfall model, and we know what are the shortcomings of waterfall model. Agile model, this is a new kind of approach these days people are using in the organization, software development organization में आजकल जो जितने भी models we have studied, they are not using that kind of approach, though they are based on these traditional kind of approaches. We need to study the traditional methods before moving towards the agile development. So this agile model was primarily designed to help a project to adapt to change request quickly. So in case of agile development, we need to respond to any kind of change request quickly. क्योंकि time बहुत कम है. We have to develop the software very quickly, and if there are some kind of changes associated in the project, that changes need to be done very quickly. Thus, a major aim of the agile model is to facilitate quick project completion. But how is agility achieved in these models? How we can achieve this agility in these models that we have studied till today? Agility is achieved by fitting the process to the project. That is, removing activities that may not be necessary for a specific project. पहले क्या करते थे? What we do in the earlier times of traditional times of software development, कुछ ऐसे फेज भी होते थे in the software development. There are some cases in that need not of concern in your project, but we do those just because we follow the SD kind of approach. But what does this agility means? Agility ये कहती है, agility ये कहना चाहती है, agility का काम ये है, agility wants removing activities that may not be necessary for a specific project. वो activities को remove कर दो. You should remove those activities that are not necessary for a specific kind of project. Also, anything that waste time and effort is avoided. So agility is quick kind of development, quick and fast kind of development, and quick response to the change request, and removing activities that may not be necessary for a specific project. So in we have agile models nowadays, and that this criteria of agile model development is usually called as, comes under the term called umbrella kind of activity, umbrella term, to refer to a group of development processes These processes share certain common characteristics but do have certain subtle differences among themselves. A few popular agile SDLC models are following. So, some agile SDLC models are given by this agility term, and they are as Crystal, Turn, feature driven development, Scrum, extreme programming, lean development, unified process. So we have two kind of approaches now for software development. One is called traditional method of software development, and they constitute the traditional models like waterfall model, iterative waterfall model, evolutionary model, prototyping model, spiral model. And another approach is agility. And agility contributes various models, and that models consist of crystal, a turn, feature driven development, scrum, extreme programming, lean development, and unified process. Out of all these development models, this extreme programming model is very much popular. So I hope now you are able to understand what is software engineering, what are the various phases of the software development, what are the traditional models that are of concern in software development life cycle. What is agility? For agility or agile software development is different from traditional method of software development. Various agile models, that are crystal, turn, feature development, driven development, scrum, extreme programming, lean development, and unified processes. Now, agile model emphasizes face-to-face communication over written documents. It is recommended that development team size should be deliberately kept small. Agile development ये कहता है कि जो development team size है, it should be between 5 to 9 people to help the team members meaningfully engage in face-to-face communication and have a collaborative work environment. It is implicit then that agile model is suited to the development of small projects. But what about large projects? However, this agile model development is suitable for small projects, but in case of large projects, it is required to be developed using the same approach of agile development. Though people are at different locations, they can work collaboratively on video call on devices that contribute to the collaborative teams. Advantages and disadvantages of agile methods. The agile methods drive much of their agility by relying on the tactic knowledge of the team members. ये tactic knowledge पे work करता है about the development project and informal communication to clarify issues rather than spending significant amount of time in preparing formal documents and reviewing them. कहते हैं कि you should consume, in case of agile development, you should consume more of your time about the development of the project and informal communication to clarify issues rather than spending significant amount of time in preparing formal documents and reviewing them. What does this mean? इसका मतलब ये है कि suppose I am developing a project. I have given some kind of module for development. I am coding that module, and there are some issues that need to be discussed with the other software engineer who is developing on his on his site. उसको भी एक module मिला हुआ है for development, and we need to talk, we need to communicate about that project. But what we can do in the traditional kind of approach, मैं क्या करूंगी जब वो बंदा क्या करेगा, for communication will issue a kind of order or office circular that we need to talk regarding this matter, and we can say formal kind of communication arrangement should be made if we are following a traditional kind of approach. But agility ये कहती है we should not form a formal kind of communication approach. We can communicate on the phone and can discuss on video that these are the issues in my module, these are the issues in your module, you can solve these issues like this, and I can solve these issues using this kind of approach. Or you can tell me what kind of uh, uh, solutions you can provide to my problem, and it is a informal kind of approach. अगर formal में जाएंगे, we will spend much of our time in significant amount of time in preparing formal documents and reviewing them. So agility removes such kind of formal communication and follows more time on development project and informal communication to clarify issues. Though this eliminates some overhead, but lack of adequate documentation may lead to several types of problems. But agar we are not keeping any kind of documentation, adequate documentation, this will lead to some kind of or several types of problems. Which kind of problems are there? Lack of formal documents leaves scope of confusion. अगर फॉर्मल डॉक्यूमेंट्स नहीं होंगे तो एक कंफ्यूजन रह ही जाएगी. उन्होंने बोला होगा आपने ये चेंजेस कर लेना और मैं ये चेंजेस कहूंगी उनको कर लेना. एंड नाउ आफ्टर देयर इज अ, जब प्रॉब्लम आ जाएगी, देयर विल बी अ प्रॉब्लम, विल कीप सेइंग कि इसने ये बोला था और उसने ये बोला था. बट इफ वी हैव डॉक्यूमेंटेड एवरीथिंग, वी हैव डू, हम उसमें मार्क करेंगे who's given the responsibility to clarify that particular issue or to clear that issue or to resolve that issue. So in kind of formal kind of documentation, we can easily come to some kind of conclusion and can remove the confusion regarding important decision taken during different phases, and can be uh, the things that cannot be misinterpreted at later points of time by the different team members. In the absence of any formal document, it becomes difficult to get important project decisions. अगर आप formal documentation नहीं करोगे तो important decisions को आप जो है उनका एक कोई proof नहीं रख पाओगे कि ये कब लिए थे, क्यों लिए थे, and design decisions to be reviewed by external experts. If there is no documentation, so we cannot show anything to the external experts, because we are talking everything informally and we are communicating face to face. So there may be possibility we cannot discuss our design issues with the external experts. When the project completes and developer disperse, maintenance can become a problem. हाँ, एक आज 100 बंदों की टीम है, they are working on a project. After development of a project, informal kind of communication, we have developed the project and it is working according to the customer requirement. But later on, whenever we need to maintain that software, with the passage of time, कुछ bugs or errors आ गए हैं, we cannot see the documentation to correct those errors because we have not maintained formal kind of documentation just because of agility of that very project. हमने एक agile software development किया था. So other person who are joining the company and जो छोड़ गए हैं उनमें कोई communication नहीं है. तो जो जिन लोगों ने those who have joined, they are not able to understand how this software was developed. अगर उनको यही नहीं पता होगा ये कैसे बना था और ना ही कोई documentation मिलेगी, for them it will be very difficult to maintain that document. Maintenance can be a big problem in case of agility. Now next topic is requirement analysis and specification. Requirement analysis and specification क्या है? We need whatever we are finding in the form of requirement of a project, we need to maintain a kind of document, and that document is called SRS, Software Requirement Specification Document. ठीक है? What this document consists of? It consists of our requirement analysis and their specification. The analyst, so a system analyst, starts requirement gathering and analysis activity by collecting all information from the customer, which could be used to develop the requirement of the system. The person analyst will gather the requirement and analyze those requirements by collecting all information from the customer, which could be used to develop the requirement of the system. He then analyzes the collected information to obtain a clear, thorough understanding of the product to be developed. वो उसको analyze करेगा collected information को and will come to a clear, thorough understanding of the product to be developed with the view to remove all the ambiguities, all the confusion, all the inconsistencies from the initial customer perception of the problem. जो भी स्टार्टिंग में कस्टमर को परसेप्शन है उसकी सेट है उसमें जो प्रॉब्लम्स that are arising, that is a duty of the system analyst. And system analyst is a person who with the software developer will keep a record or will update the information related to the document called software requirement specification document. So analyst का role क्या है, क्या क्या duties है? Analyst will see what is the problem, why it is important to solve the problem, what are the possible yes, who is this Mia Khalifa? Anjali, this person is from your class?
No, ma'am.
Move कर दिया. What are the possible solutions to the problem? Well, next time you are to log in with your registered roll number and your name. मैं इसकी setting ही change कर देनी है. What are the possible solution to the problem? What are exactly are the data inputs to the system? And what exactly are the data outputs by the system? What are the likely complexities that might arise while solving the problem? क्या क्या complexities and what are the various ambiguities and what are the various issues that might arise while solving a particular problem? If there are external software or hardware with which the developed software has to interfere, then what exactly would the data interchange formats? So if there is any kind of external usage of software or hardware, so what will be the interface you are using, and then what exactly would the data interchange formats, or you can interchange the formats with the external system that you will be using. So these kind of issues, these kind of problems, these kind of questions come in the mind of the analyst, and analysts need to write these questions on the, we can say, need to prepare in the form of requirement specification document. वो orally इतना कुछ याद नहीं रखता. For larger projects, everything cannot be remembered in your head only. You need to have a proper documentation for a particular project, for a particular module, for a particular kind of module that you are developing, so that you can give it to the other person later on when you are leaving the company. The other person can also understand how this whole software was developed and how he or she can maintain that software later on with the passage of time. So software requirement specifications document, this are this is called SRS document. This has some important parts that constitutes functional requirements of the system. Functional requirements क्या हैं? Functionality क्या है? What are the known functional requirement of the system? And what are the goals of implementation? We'll talk about functional requirements of the system first. From the functional requirements, this part discusses the functionalities required from the system. From the functionalities point, we mean uh, the things that have some kind of inputs and outputs associated. Like the system is considered to be perform a set of high level functions, FI. The functional view of the system is shown in figure. Each function can be considered as a transformation of the set of input data to the set of corresponding set of outputs. So here in your diagram, you can see functional requirement specify means giving some input to the system or module, and there will be some kind of processing in this box and converting these inputs to some kind of outputs. So here you can see the inputs are from I1 to IN. These inputs are given to some system or process, and these outputs in the form of O1, O2, ON are coming. For a better understanding of functional requirement, I'll give you an example. Consider the case of library system. And suppose आप कोई library management system कोई software बना रहे हो, and you're creating a search book function. Search book का एक function you want to create. That is a functional requirement. For creating a search book function, what will be the input to your system? आप किसी book को search कैसे कर सकते? You can search the book from the title, or you can search the book giving an author name. ठीक है? अब किसी book को कैसे search कर? You can search the book using the author name. So input can be author name, and what will you getting as an output? You will be getting as an output details of the author's book and location of those books in the library. आपको डिटेल मिल जाएगी ऑथर बुक की और किस शेल्फ पे पड़ी है वो बुक्स लाइब्रेरी में. दैट विल बी द आउटपुट ऑफ दैट वेरी फंक्शन. So there cannot be one function in the system. There can be more than one function. आप कितने भी उसके टाइप के फंक्शन और बना सकते हो. This is just an example that I am giving to you. So these are the, we can say, the functional requirements of the system. So can you name any functional requirement you feel that can also be possible in library management system project? कोई बता सकता हो? Any student who can tell me this is the functional requirement in my project? Anchal or anybody in your class? Nobody? Anchal, I'm not getting your voice. Are you speaking?
Ma'am, now I'm audible.
Nobody knows any kind of functional requirement in their projects they have developed so far. First year में कुछ तो बनाएंगे management projects you might have done. Anyhow, आपको clear हो गया what are functional requirements of the system? They must have some kind of inputs, processing and outputs. Those are called functional requirements. So moving ahead, what are the non-functional requirements? Non-functional requirement deal with the characteristics of the system which cannot be expressed as functions. जिनको हम functions के form में express नहीं कर सकते. We cannot express in the form of function, but they are very useful for project point from the project point of view. Like we can say portability is one of the non-functional requirement of the system. Means you are developing an application and you want this application to be shifted to another device or another we can say platform. So that is a kind of portability must be required by every developer who are developing a particular kind of application. अभी आप देखते हो students are developing application, engineers are developing application that are hardware independent, that are platform independent. So that is a basic approach of portability, reliability, maintainability. So such kind of requirements are non-functional requirements. ठीक है, आप reliability of a software is non-functional requirement, but that is very much necessary in your project. Reliable होना चाहिए आपका project. Usability is one of the feature that comes under the heading of non-functional requirement of the system. Can you give an example of non-functional requirement that is of very much use and is being used by e-commerce companies while developing e-commerce softwares? Amazon पे भी non-functional requirements जो है Amazon के software हैं, we have very list of a long list of non-functional requirements. Nobody? सुन भी रहे हो? Are you listening?
Yes.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes,
Okay. लग तो नहीं रहा है you people are not doesn't know about a non-functional requirement. मैंने बता भी दिया. Even then you people are not able to identify non-functional. So maintainability, reliability, and usability, portability are some of the non-functional requirements of the system. So next is goals of implementation. So goals of implementation are some of the trade-offs, or we can say suggestions regarding development. These suggestions guide trade-off among design goals. Trade-off का मतलब होता है kind of negotiation. कोई चीज बढ़ा देनी, कुछ कम करनी. The goals of the implementation section might document issues such as revision to the system functionalities that may be required in the future. We need to mention that we are developing these functionality, but these functionality we need to be see in the future also. New devices to be supported in the future. हमने आज software develop कर रहे हैं. We are developing software in today's time in 2020. But we'll see after 10 years what are the goals of what are our goals. ये project कितना feasible होगा, कितना useful होगा, can we shift this project into another platform. So this kind of things are called goals of implementation. New devices to be supported in the future. Reusability issue, क्या मैं सॉफ्टवेयर को रीयूज कर सकता हूँ. What will be the reusability issues. अगर मैं इसको दोबारा रीयूज करना चाहता हूँ तो मुझे क्या इश्यूज आएंगे in 2030. These are the items which are the developer might keep in their mind during development, so that the developed system may meet some aspects that are not required immediately. So these will be called as goals of implementation. I hope this thing is clear to everybody.
Yes, ma'am.
Next topic is software design. This is one of the phase of software development life cycle. Software design क्या है? It is a process to transform user requirements into some suitable form, which helps a programmer in software coding and implementation. So one thing is clear, this design phase comes before coding and implementation. And this design phase helps in coding and implementation. Software design is a first step in software development life cycle, which moves the concentration from problem domain to solution domain. अभी तक हमने जितनी भी बातें की हैं, whatever we have discussed related to software development life cycle and the various phases we have discussed till date, they are concerned with the problem domain. भी क्या होना चाहिए, ये होना चाहिए जी, कितने एनालिस्ट होंगे, क्या क्या मॉड्यूल्स, व्हाट विल बी द मॉड्यूल्स, व्हाट विल बी द क्राइटेरिया, क्वेश्चन मार्क है, एवरीथिंग इज इन द फॉर्म ऑफ what we are going to develop, how many modules will be developed, what other things need to be considered, what are the functionalities, what are the functional requirements, what are the goals of implementation, what are the non-functional requirements. ये सारे questions are that means we are in the problem domain. Now, in case of software design, what we are doing is we are moving from the problem domain. How से हम move करें कि हम उनको अब बनाने पर आ जाए, उनको develop करने में आ जाए, उनको design करने में आ रहे हैं. So we are moving from problem domain to the solution domain. It tries to specify how to fulfill the requirement mentioned in SRS. SRS is Software Requirement Specification Document. और ये document जब हम requirements, whenever we are specifying the requirement, we prepare this document. Now we are we are converting this document solution of these things that are jotted in this document SRS. जो भी SRS में what, how, when, why, उनका solution अब हम बनाने चाह रहे हैं in the form of software design. So we are moving from problem domain to solution.
नहीं हो रही सुनती मेरी गल्लें ਤੁਹਾਨੂੰ ਮਾੜੀਆਂ ਲੱਗਦੀਆਂ ਵਾ.
What is the problem with all of you? Who is this person? सॉफ्टवेयर डिजाइन इज द फर्स्ट स्टेप. ये आपको बता दिया मैंने कि वी आर मूविंग टुवर्ड फ्रॉम प्रॉब्लम डोमेन टू सॉल्यूशन डोमेन. नेक्स्ट इज, हाँ जी आंचल, इज देयर एनी क्वेश्चन?
Yes, ma'am.
Okay.
Ma'am, we did that agility models. We studied that over there, no preference is given to documentation kind of steps. तो मैम वहाँ पे SRS kind of documentations भी नहीं बनते.
In case of agility models, there are SRS kind of documentation, but we know we can say we are not referring to them as SRS document. We are referring to them in the form of another kind of document, or according to the document of the model, particular model documentation of it. Like हम extreme, whether we are following the Scrum approach, whether we are following extreme programming, or any kind of other model in the agility, we are writing their documentation. हमें मतलब thing is, concern is we need to write those things that are important to us. हम हर एक चीज की छोटे छोटे detail, whatever we are writing in the form of smaller and smaller details in the traditional models, that we are not writing in the agile models. So just because to save our time in the and putting more time on development rather than on the documentation. हम करते तो हैं, ऐसा तो नहीं बिल्कुल ही we are totally on the we can say face to communication or oral kind of communication. We need to have a documentation for developing such large projects for various companies. कोई छोटे छोटे प्रोजेक्ट थोड़ी ना होते हैं जो आप क्लास में डेवलप कर रहे हो. These are not the projects you are going to develop in your companies. They are larger projects. They are given in the form of modules, and you have to maintain some kind of documentation. It is up to the developer, or the we can say the team leader, who is assigned the duty of writing the documentation of to a particular person or particular team. You might have seen that you have while using some kind of devices, हम mobile phone use कर रहे हैं, we have a documentation for those things also. आपको manual मिलता है, you have a manual for we can say TV, you have a manual for any kind of instrument or any kind of device, digital or device you are using. So those need to be maintained. हम ये हर चीज को orally बात नहीं कर सकते. So documentation are there, but they are not that formal जो पहले होती थी. Now we are moving towards software design levels. So we have 3 levels: architectural design, high level design, and detailed design. Now architectural design. The architectural design is the highest abstract version of the system. It identifies, this is the abstract version of the system. Mind it, abstract means you are getting external view of the system. Internal details are hidden from the we can say to the user. It identifies the software as a system with many components interacting with each other. At this level, the designer gets the idea of proposed solution domain. Only it gets an idea of the proposed solution domain. Internal details are not are hidden. So that we can say only the architectural, or we can say only एक हमें ढांचा सा दिख रहा है, architectural design. So that is called architectural design. Yes, Amisha, what is the problem? So next is high level design. The high level design breaks the single entity multiple component concept of architectural design. Means there is a single entity conversion to multiple component concept of architectural design into less abstracted view of subsystems. Now, in the case of architectural design, there is more kind of abstraction. Abstraction, what does abstraction mean? Anyone from your class? You know what is abstraction? Or should I tell you? Abstract view क्या होता है? Is there anybody who knows what is abstract view? Okay. Abstraction is in whenever internal details are hidden, how the functionality will work, how the functionality will going to work is hidden, and you get an external view of the system. That is called abstract view. So in the architectural design, the view is more abstracted. Internal details are hidden. But in case of high level design, the view is less abstracted view of subsystem and modules and depicts their interaction with each other. पिछले में क्या था? In the case of architectural design, interactions are totally hidden. You cannot see the interaction between the subsystems and modules. But in case of high level design, you can depict their interaction with each other. High level design focuses on how the system along with all its component can be implemented in form of modules. एक system कैसे module की form में, or the system will work in the form of modules, or the modules will interact with each other, that is in the form of high level design. It recognizes modular structure of each subsystem and their relation and interaction among each other. So in this, you can very well imagine in case of high level design, how the modules will be interacting, how the subsystem will be interacting, what will be the modular structure of each subsystem, and their relation among them is discussed in high level design. Third level of design is detailed design. In case of detailed design deals with the implementation part, what is seen as a system and its subsystem in the previous two design. So detailed design, as the name implies, is the overall in detail description of each and every component in the system. It is more detailed towards मॉड्यूल की और ज्यादा डिटेल में हम जाते हैं, उसको डिटेल डिजाइन बोलते हैं. And their implementation, it defines the logical structure of each module and their interfaces to communicate with each other module. So we first view is as architectural view, next is high level design, and third is a detailed design. So three levels of design are there in software design. Next is modularization. Modularization term क्या है? What does this modularization term mean? It is basically an approach to divide software system into multiple discrete and independent modules, which are expected to be capable of carrying out tasks independently. These modules may work as a basic construct for the entire software. The designer tend to design modules such that they can be executed or compiled separately and independently. So in case of modularization, what does modularization mean? It is another term for dividing the system into subsystems. मतलब क्या है? You are dividing your problem into or system into subsystem, and the same is a concept with the modularization. Basically, you are dividing this particular problem P1 into different modules. So that may be in the form of module 1, module 2, or module 3, and so on. It is up to the developer or the analyst who will decide how many modules for a particular system you are going to develop. So modularization is a technique to divide a software system into different modules and multiple discrete modules that are independent. Basically, independent modules will be considered, which are expected to be capable of carrying out tasks independently. These modules may work as a basic construct for the entire software. So you can see here this problem P1 problem, and there are three modules with name with the name the M1, M2, M3 here. Modular design unintentionally follows the rules of divide and conquer approach, uh, problem solving strategy. This is because there are many other benefits attached with the modular design of a software. So before moving further, there is one poll associated with the previous topic. Kindly answer these questions. The Dash model was primarily designed to help a project to adapt to change request quickly. Another one is number 2. Dash is a process to transform user requirements into some suitable form which helps the programmer in software coding and implementation. Still half of the class has not answered to these questions. Kindly quickly answer these questions. Time is running very fast. Whether it's a agile approach or a traditional approach in the first question, and what is this process is called, whether it's design, software design, or coding. Very simple and easy questions. Both of these questions are very simple and easy. Still some students are bending. Kindly reply. I am ending the poll in 2-3 seconds. So answer to these questions are, in the first question, the agile model was primarily designed to help project to adapt to change request quickly. So the answer is agile. In the next question, um, Dash is a process to transform user requirements into some suitable form, which helps the programmer in software coding and implementation. So that phase is called software design, is the process to transform user requirement into some suitable form, which helps the programmer in software coding and implementation. So first question answer is agile. In the second question answer is software design. Now we are moving towards advantages of modularization. So smaller components are easier to maintain in case of modularization. Programs can be divided based on functional aspects. So we can divide a problem or program based on the functional aspects. Desired level of abstraction can be brought into the program. Components with high cohesion can be reused again. Concurrent execution can be made possible, and desired from security aspects. Modularization is required or desired from security aspect of the system. So these are the some of the advantages associated with modularization. Now next topic is coupling and cohesion. When a software program is modularized, its tasks are divided into several modules. I have told you earlier that this every problem is divided into modules. That dividing of problem into module is called modularization. Based on some characteristics, हम उनको क्या divide करते हैं? Based on their characteristics, we are divide the problem into modules. As we know, the modules are set of instructions put together in order to achieve some task. They are tough. They are though considered as single entity, but they may refer to each other to work together. Every module is basically divided into a strict single entity, and though they work with each other through interactions, there are measures, or we can say metrics, by which we can uh, measure the quality of design of module, and their interaction among them can also be measured. These measures are called coupling and cohesion. So, the two concepts are associated with the modularization. One is called coupling and other is called cohesion. So, they both are concerned with modularization. What is cohesion? Cohesion है क्या? Cohesion is a measure or a method term that is used to measure the degree of interdependability within the elements of a module. So in case of we can say in case of uh, cohesion, what does this mean? It means the degree of interdependability within the elements of a module. I told you earlier that what is modularization. Modularization is dividing the problem into module. अब एक module we have one module, two module, three module, but we will not discuss the uh, will not discuss the interaction among modules. We'll discuss the dependability within the elements of a module. We'll discuss a single module and the element inside it. So you can see if the elements are interacting, whether it's good they are interacting within the module or not. So that is the basic concept in modularization and cohesion. So in this diagram, I am drawing the diagram. Will show you how this is going to work in case of modularization. In the diagram here, you can see in the board here, you can see there is a problem, and this problem is being divided among two modules M1 and M2. And you can see here in the M1 there are stars. These represents the components of module M1, and there are some dots in the M2. These represent the components of M2. So the cohesion, what does this cohesion is saying? Cohesion ये कह रही है, cohesion is a measure that defines the degree of interdependability within the elements of a module. The greater the cohesion, the better is the program design. So you can see here, अगर ये stars में अपने आप में interaction है, if they are interacting with each other and they are depending on each other more, then cohesion is more. Your project or your problem is more good, or we can say the solution to that problem is more good. But if the components are not dependent on each other within a particular module, एक ही module में बात कर रही हूँ, I am talking about a single module, that is the M1. The components, these stars are interacting with each other and they have a strong bond with each other. Then this kind of approach we can say is good for better program design. So Cohesion is a measure that defines degree of interdependability within the elements of a module. The greater the cohesion, the better is the program design. So there are different types of cohesion. The number of types of cohesions are seven. Seven types of cohesion is there: coincidental cohesion, logical cohesion, temporal cohesion, procedural cohesion, communicational cohesion, sequential cohesion, and functional cohesion. So we'll discuss every cohesion here, starting with the coincidental cohesion. Now, what is coincidental cohesion? It is unplanned and random cohesion. It is not any kind of planned cohesion by the developer. It is unplanned cohesion, and which might be result of breaking the program into smaller modules for the sake of modularization. So breaking the problem into smaller modules for the sake of modularization. And coincidental means the components, the star here in the module M1, which is showing in the diagram on the board here, these are, they are put it based on coincidence. That matlab ki jo bhi stars and the things they are inside that particular module, they are coincidentally placed in the module M1. They have not any kind of particular kind of relationship among them. Either udhar se pakde and we are placed in one module that is called M1. Because it is unplanned, it may serve confusion to the programmer and is generally not accepted. So this kind of approach, that putting together some components in a module that have not any specific relation with each other is called coincidental cohesion. So मेरे पास ऐसा कोई I am developing a project for software for like this college management system or university management system. So there may be some forms that are very random and I don't know where to put those forms. So मैंने एक अलग से I have created another module and placed some kind of functionalities in a particular module, and that may be called as coincidental cohesion because उनमें कोई interaction ही नहीं है, बस फॉर्म्स को एक मॉड्यूल के अंदर मैंने डाल दिया एक्सीडेंटली और with unplanned planned contribution to that particular module. Next is logical cohesion. When logically categorized elements are put together into a module, that is called logical cohesion. The things that are related with the components of that particular problem domain are related logically, so they will be called as, the components are logically cohesive. Next is temporal cohesion. I'll give you an example of these terms also. Logical cohesion ki bhi aapko example I'll give you that. We'll study first and we'll give you example later on. Next is temporal cohesion. When elements of module are organized such that they are processed at a similar point in time is called temporal cohesion. So temporal cohesion is when putting the things together and they are triggered at the same time. They are called temporal cohesion. So we can say example of temporal cohesion can be given in the form that you are giving online test, and whenever you are giving that you are ending your test, and immediately your report is being generated that you have scored so much of your marks, that we can say they are temporally cohesive. जैसे ही आपने उसको complete किया, whenever you are giving the test and you have completed the test and you are clicking on completion, or immediately a report is being generated related to that test. That is a kind of temporal cohesion. That is that the things are done at the same instance of time, or any activity that is happening at the same instance of time and is triggering many functionalities at that time is called temporal cohesion. Next is procedural cohesion. When elements of modules are grouped together which are executed sequentially in order to perform a task, it is called procedural cohesion. When कुछ ऐसे elements we are putting elements sequentially, Sequential means we have components that will result in the solution to a particular problem. But we need to run those elements in the form of sequence. That will be called as sequential cohesion. और procedural cohesion. एक procedural program क्या होता है? Basically the steps are taking place in the form of sequence. Sequence means instruction 1, after instruction 1 there will be instruction 2, after instruction 2 there will be instruction 3, 4, 5. If there are 7 instructions, they will be executed in sequence of 1, 2, 3, 4, 5, 6, 7. So such kind of elements that are triggering one after the another according to some kind of sequence will be called as procedural cohesion. Next is the communicational cohesion. In case of communicational cohesion, when elements of modules are grouped together which are executed sequentially and work on the same data. So they are the things in procedural and communication is same is that in communicational cohesion the things are happening sequentially but they are working on the same data, and that will be called as communicational cohesion. Why the communication word is coming? Just because the data that is output from the particular phase is input to another phase that is coming next in the sequence. So that kind of communication, that kind of cohesion is called communicational cohesion. Next is sequential cohesion. When elements of module are grouped together because of the output of one element serve as input to the next, that what I am saying is that is sequential cohesion. That is also communicational kind of cohesion. So uh, sequential cohesion is basically when output of one element serve as an input to another, that is called sequential cohesion. Next is functional cohesion. It is considered to be the highest degree of cohesion. From the highest degree of cohesion we mean that is uh, the module having the highest cohesive degree. We can say the most cohesive is the functional cohesion. It it is highly expected. Elements of the module in functional cohesion are grouped because they are contribute a single well-defined function that can also be reused. So if there is a single function and all the elements of a particular module are contributing to generate a single output, that will be called as functional cohesion, and that functional cohesion involves contribution of all the elements in the module, and that is called functional cohesion, and that is the maximum cohesion that a project can achieve. So from the all these cohesion, the coincidental cohesion has least cohesion, this coincidental cohesion, because they are put into a particular module randomly or coincidentally. So it has least cohesion. This coincidental cohesion has least cohesion, while this functional cohesion has maximum cohesion associated with it. So this is the basic difference between the coincidental and functional cohesion. Anchal.
Ma'am, we said that in procedural cohesion, it is also arranged sequential.
Anchal, I am not getting your voice.
Hello, ma'am, I am audible.
Is there any issue?
Ma'am, am I audible now? Hello.
Next is coupling. So, what is coupling? Coupling is a measure that defines the level of interdependability among the modules of a program. So coupling cohesion से क्या differ करती है? Whenever we were talking about the components of particular module, like we are talking these are basically elements of a module. If the elements are interacting with each other, we say that the module is highly cohesive. But whenever there are interaction among different modules, m1 अब m2 से बातें कर रहा है, interact कर रहा है, kind of interaction or exchanging some kind of information or giving input or giving some kind of input to the other module, that kind of concept is called coupling. Coupling is a measure that defines the level of interdependability among modules of a program. It tells that what level of module interfere and interact with each other. The lower the coupling, better the program is. So jitni kam interaction, or we can say the little the interaction is good, that system is. If there is more coupling, that system is not good for implementation. So this is the basic difference between coupling and cohesion. You should have high cohesion in your project and less coupling in your project. That is the main concern here in case of coupling. So we have different types of coupling. We'll discuss those types in the later lectures, because today it will not be possible to complete the various type of coupling and their examples. Will cover only an idea of what is coupling. So in the diagram here you can see there are two module M1 and M2. They are interacting with each other. और ये M1 रह ही नहीं सकता. M1 is totally dependent upon M2. Such kind of things in which there is a strong connection between module between one and two, M1 and M2. This kind of things need to be avoided because they are independent modules. Interoperability should be minimum, and in case of coupling तो वो कम होनी चाहिए. That is the concern, and we should have least coupling and high cohesion for a better development of our project. That is the concern here. Is there any question related to this um, coupling? So Ancha is saying, what is the difference between procedural cohesion and sequential cohesion? In case of procedural cohesion, procedural and sequential, you are saying sequential cohesion. In case of procedural cohesion is basically when you are doing some kind of operation on a file, and before opening a file you are checking file permission. That is we can say a procedural kind of cohesion. But sequential is when the component part of output of one is input to another. That is sequential cohesion. Function that reads the data from a file and process the data, that is we can say sequential cohesion. But procedural cohesion means whenever we are when parts of modular group, because they always follow a certain sequence of execution. They will always follow a certain sequence. Like मुझे कोई file open करनी है तो before that a function will check file permission and then open the file. That is a procedure that need to be followed every time. In case of sequential, one of the output is input to the next element in that particular module. I hope कि आपको clear हो गया हो what is procedural and sequential. So that was today's lecture all about cohesion and coupling. We'll discuss coupling in detail, and we'll also discuss some of the issues, the things that are not you are getting like what is the difference between those terms and what are the example we can write in the paper or we should know uh, here. So in the next lecture we'll start with the topic coupling and we'll discuss examples of cohesion. So this was all about today's lecture. Thank you. And there is one poll, if you allow me, we'll have that poll today. Kindly answer these questions quickly because we don't have much time here. All are required to answer these questions. That this will mark your attendance of today's lecture. 4 times the lecture attendance is taken every time whenever a poll is generated. Dash is a technique to divide a software system into multiple discrete and independent modules, which are expected to be capable of carrying out tasks independently. It is called modularization or abstraction. Next is modules and their interaction among them can be measured. These measures are called coupling, cohesion, or both. Kindly answer these questions. Only 20 more seconds. Amandeep, is there any issue? So I'm ending the poll. First question's answer is modularization is a technique to divide a software system into multiple discrete and independent modules.